an interdisciplinary field to extract knowledge or insight from various types of data, from unstructured, structured, small, and big data, which is actually the continuation of data analysis using data mining approach, using machine learning, using artificial intelligence, and so on. But today we have a new definition for data science. Actually, today we tell data scientist is someone who knows math and statistics, machine learning, artificial intelligence. He knows about programming and database, for sure, programming mostly R, Python, and Scala. And new things that has been added to data scientist techniques is domain knowledge and soft skills. It means that if you want to be a data scientist, you have to have some knowledge about the field that you are going to work on. For example, if you are going to be a data scientist in a finance system or banking system, you definitely should have some knowledge about the banking system. If you are going to work in a healthcare system, you should have some domain knowledge in healthcare system. And it's why it has made this field of a study or this career a bit challenging. And other than that, you should have communication and also visualization skills to just tell the story about the data, just to take out the result from your data and just convey it to your customer or your manager and so on. So the question that sometimes comes to mind is that why we should learn data science, first of all. And I found actually there are a few reasons. First of all, data science can be used for social good. Right? Last year, UN has released 17 goals, sustainable goals, and we thought that data science is a UN goal. Just to give you an example, there is a company, I think its name is Give Direct. This company is supposed to collect some money from international charities. It's a non-profit company, and direct this money to the poorest people in Africa, right? And the way that they used to do is just sending some representatives to different villages in Africa because the census are not reliable or doesn't exist. And the money that this company paid to these representatives to send them, for example, to Kenya is much more than what this company is supposed to help the poorest people. So some experts from IBM has, with another company, I think his name is Enigma company, came together and they used satellite images to just find the poorest regions in Africa. And the way that they did was just to look at different houses in the village. There are some houses that the roof is thatched roof, and some of them are metal roofs. And they found that the areas of village that have most metal roofs, they are more rich, and the roofs that are thatched are usually the poorest people and are actually a good target for helping them. So you can see that they could use some kind of big data, data science, and image processing all together to recognize these people and direct the money to these areas. Also, we can have usage of data science in industry, right? Last week, I was giving a talk in Mumbai. One of attendants asked me that, Saeed, already there are many algorithms, many techniques in data science, like recommender system, like, I don't know, classification, other things that big companies are using this, right? For example, Amazon is using recommender system. So what's the point that we learn recommender system or other things? And the things that these companies needs are usually data engineering. It's people who extract data from data sets, from different data sources, and integrate this data and just pass to the data scientists. And if already there is recommender system, so what's the point for data science? So I wanted to, actually I answered this question with one example. Around, I know, 7 or 8 years ago, I was a company, an insurance company, approached me and told me that we have a big data set, and we have a data set of automobile accidents, right? And we had a good revenue in the last 2 or 3 years ago, and still our revenue is not bad, but there is some kind of rumors that we have some frauds and people can play with our system. So, say, can you help us with this data? So, and I accepted and started analyzing their data, right? But the problem was finding fraud in this kind of data set wasn't that easy, because usually fraud detection in normal way is you find some kind of patterns of fraud. For example, in banking system, you find the patterns of the transaction that are possibly fraudulent or something, and based on some approach like neural network or other things, you just classify some transaction that, okay, it can be fraud or not, right? But in their system, they didn't have any fraud, so we didn't have any patterns of fraud in their system, and I had to come up with a new approach for their data set. Anyway, I analyzed their data set using different approach with the new approach, and I solved the problem. I went to manager and I told him that I have a good news and a bad news. The good news is that I found the patterns of the fraud, and I know that what's going on there. The bad news is that it's not your client who are doing the fraud. These are your representatives in different cities who are doing that, right? So my point is that it's not always some kind of existing approach like recommender systems or classification or clustering that you can use for solving a real world problem. Sometimes you have to combine many things in data science and create a new things for actually solving the problem. So there is another new field also which is emerging recently, and it has been driven from data science, which is called data journalism. Democratizing data, it's a new field actually. Let's say something happens in some place in the world. For example, we have an earthquake in Indonesia, for example, right? And what usually reporters do, they just write some line of codes, report what's going on about this disaster, and I believe they usually go to Google, search for that disaster, and just write at the end about the previous or historical or same situation that exists in Indonesia or other countries as well, right? But new field of data journalism, actually I don't usually read after 4 or 5 lines of the news. But new data journalism field can connect to some kind of data sets, the data set that are open source. They can analyze their data, and instead of writing many actually textual reports or news, they just give you a chart, a pie chart, I don't know, a trend of the earthquake or whatever. And it would be much interested to just follow up, to just take a look, right? Instead of reading the whole line. So it's a story about data journalism. And other than that, there is a demand and supply in data science, right? For example, McKinsey has reported that we need 200,000 data scientists in 2018 in USA. So it's huge. There is a huge actual demand for data scientists. Or Glassdoor, most of you maybe know Glassdoor, is one of the best job search engines in the world. In January 2016, has released a report about the best jobs that everyone has to pursue. And data scientist is in top rank in terms of the salary, in terms of the opening opportunities, and other things. So it's really high demand for this one. And I'm sure that many of you have heard that data scientist is the sexiest job in 21st century. I hope you don't see me as sexy, but it is really a good job. And it's a very exciting job because you analyze your data and You extract something from your data in 2 or 3 sentences. You can tell a story about a very, very big data like 1 TB or 2 TB. So it's really a rewarding job, but it has some problems. Exactly same as the models that always try to be sexy, right, and keep themselves well fit. You also have to keep learning, always keep learning, and sometimes there are many inconsistencies in the data sets. You have to come up with the new algorithms, and it's not really easy. I should use that one. Let's start with it. I cannot find this one. Okay, so it's a story about data science. And what we are doing in IBM, IBM has committed to educate 1 million data scientists, right? Last year, IBM has announced a major commitment to advanced aperture for collision potential as the most significant open source project for the next decade. So we, in our team in IBM, we thought that how we can help people to just educate them. And we found that there are 2 problems. The first problem is a skill, and the second problem is tools, right? And to overcome these 2 problems, for skills, we came up with Big Data University and some meetups. And for tools, we came up with Data Scientist Workbench. So let me just explain a bit what is Big Data University. I think most of you know about Coursera, right? So Big Data University also is a MOOC like Coursera, but our focus is only on big data and data science. So all of the courses that we have in our websites are about big data and data science, about Hadoop, Spark, R, analytics, Scala, Python, and so on. So if you go to this website, you can see many learning paths, right? You can start, for example, learning path with Scala. It's Scala with introduction to Scala, then it goes to data analysis with Scala, after that visualization with Scala, machine learning with Scala, and finally Spark and Scala. So it's a complete learning path that starts for with the beginner level and goes to advanced. And one of the good things about the Scala is, I think 1 or 2 of our courses has been developed by the actually person that has created the Scala. So what is this Big Data University? The address is bigdatauniversity.com. It's a community initiative led by IBM. The good thing is that you can take courses at your pace and your place. And all of our courses are online courses about data. Most of the courses have been developed by industry experts, not all by IBMers, but some of them are being developed by IBMers. All of the courses are free. The whole site are free. You don't have to pay anything for the courses, to take the courses, and nothing. And you get the certificate of completion and badge. If you complete the course, you get the certificate, and if you complete the path, you get the some IBM badge. The address is bigdatauniversity.com. You can go and take some courses there. We have a rule of thumb in Big Data University. We tell that we have rule of 5-5-5. It means each course has maximum 5 lessons. Each lesson has maximum 5 videos, and the videos are not more than 5 minutes. So usually the courses are very short. They are not lengthy courses. And we believe that if the course is very short, the chance that students finish it is much higher than very lengthy courses. And each lesson has a hands-on lab using VMware, Docker, or Cloud, or Data Scientist Workbench. Each course has a multiple choice of 20 tests, so you can easily pass each course. And as I told you, usually they are short. not 4 hours, maybe 5 or 6 hours, you can finish the whole course. And if you want to find a course, you can easily go to Google and search, for example, Big Data University, Spark. You can find, for example, Spark Fundamental 1, Spark Fundamental 2, and you can take that courses and use it. So we have bigdatauniversity.com. In English, we have in Portuguese, in Chinese, and I know that we are going to start in French as well. To support our Big Data University, we have some meetups just to support each of these courses, right? For example, we have Toronto Big Data University, the first meetup that we have started, and we have now more than 4,000 members. From the January, we have started January of each year, we start a series of courses. We start with R, Python, and Scala. Then we go for data analysis with R, Python, and we go until the machine learning. We have this meetup in Vancouver, Washington DC, in Montreal, Ottawa, Tokyo, Chicago. Hopefully we will start in Mumbai and Bangalore as well. And by 2 weeks we will start in Shanghai, another meetup for Big Data University as well. So the good thing is always we have live streaming for our meetups. So if you want, you can go to bigdatauniversity.com/events, and you can see all of the previous recorded videos for our courses. All of the materials also are there. You can download the materials. Or for the future meetups, for example, we have another meetups in 2 days. If I'm not mistaken, Big Data with Hadoop. You can join and use the meetups in Toronto as well. And other than skills, we have tools as well. And what tools is the best tool for data scientists? Which language usually data scientists use? R. Python, R, or Scala? Raise your hand if you say R. Okay, Python? Okay, since the Python is most popular. Scala? Okay, good. So, before I talk about tools, I want to tell you another story about data science, right? 3 or 4 years ago, I was supposed to predict Forex market time series. It was a simple project. Many people, usually master or bachelor, try to do some kind of prediction of time series, right? It's very simple. Usually, for example, here we have a time series of data for Forex market. We have started when markets open at 10 a.m. and it's finished at, I don't know, 5 p.m. So let's say we have some data from 10 a.m. to 4 p.m. and I want to predict the next 1 hour. So same as other project, I started researching about existing approach, existing software. And I found most of the approaches are some kind of technical approach that use machine learning and artificial intelligence, like neural network or moving average to predict the future. And this approach are usually based on this principle that there are some kind of patterns in time series, and if you can recognize these patterns, you can predict the future, right? It's same as predicting temperature, predicting, I don't know, many other kind of time series. But I didn't want to use this approach, this technical approach, because it's very contextual and it's subjective to the domain that we are solving. For example, if we are working on a stock market of a country, the approach is very different and the result is very different from another stock market in Europe or US. So I wanted to use another approach, which is actually fundamental approach. And in this approach, there is one principle that movement of the market is based on some kind of outsourced data. For example, a war happened in Syria, it affects on the price of the oil, and it also affects on the stock market or forex. Or let's say if you have a demonstration in Hong Kong, this one will indirectly affect on the stock market. So there are some events outside of this pure forex market that are reflecting this time series data. I wanted to use this outsourced fundamental data. And what's the best source for me? I made a decision to use news. So I could collect some news from google.com, news.google.com, and I access this news aligned with my time series, right? For example, is all of the news that has been released in this day, during one day. So the next step was to just find a relationship between this news and the movement of my market. So I've sliced my data in, for example, 1.5 or 2 hours windows or 2 hours chunks, and I calculated the movement of my market. It's very easy to calculate the movement, right? It's going down, it's going up, down, up, and I wanted to predict the future, last 2 hours. And at the same time, I chunked my news as well. And I found some keywords which are very significant in this chunk, the second chunk, the third chunk. It's very easy to find this kind of keywords, right? You can easily use natural language processing to find the keywords that are most frequent, or I don't know. And for any reason, that keywords are most important. So it was very easy if I could find some kind of relation between these keywords and the movement of my market. If a new news comes up, I could predict the future of my market or my movement of my market, right? So I had a very clean data set. The data set was time number from to the keywords that I had and movement of my market, whether it's going up and down. So simply just in the net flow, I used a word vector to calculate the numerical values of my keywords. I could use, for example, TF-IDF or word vector or other efforts to just convert the textual columns to numerical values. And I could make a classification algorithm, simply like naive-based, like SVM, I don't know, decision tree, and other classification approaches to make a model, to train my model, and use that model to predict the future, right? Does it make sense? Yeah? So I converted the project to a simple data set, and I've started my work. So I had a methodology for my data science, right? And this methodology is the methodology that you can use for running a project in data science. That usually starts with business understanding, finding the analytic approach. For example, I know that I want to predict something, data requirement, data collection, just collect my data, data understanding, exploration, cleaning, preprocessing, modeling, and finally evaluation. So it was the methodology of data science that I wanted to follow. So I started implementation. So all of them were designed. Now it was time to implement this project. And my estimation for that project was around 2 or 3 weeks with all of the troubleshooting and all of the problems that usually comes in the implementation. So the way that I started implementation was scraping news with Python, and then virtualization, news mining with Python, NLTK, which is a package that is used usually for natural language processing, is very popular. Cleaning, exploration, merging, forex time series using R, and classification with Weka Rapid Miner, which that time Weka was very popular in 4 or 5 years ago. So I implemented the project, and it was very fast. And I ran it, and what was the result? I failed. My result wasn't good. My accuracy was very low. Why? Can you guess? Yes, exactly. My data wasn't enough. The news that I collected wasn't more than 50 megabytes. So I started collecting more data from Reuters, from BBC, from CNN. and also from Twitter, right? Because Twitter also is somehow a spatial temporal data. It has geographical and also temporal data. So I could align that data also with my news data. So I collected a lot of data from everywhere. And again, I started implementing my project using big data, and I use also word vector to a big bring up my accuracy, and I implemented everything with Python. And what was the result? Good or bad? Let's see why. Why? Sorry? No, the problem was that I couldn't run it on my computer, on my laptop. The dataset was very big, and I couldn't run it on my laptop because of the speed. Maybe I could run it, and it took, for example, 2 or 3 hours to finish it. But the problem of this project is that always you have to tune it, right? Always you have to change the, for example, kernel of your support vector machine. You have to change many parameters, and you have to run it many times, right? Stopping words for natural processing, for language processing part, and many things. So I thought that I can use Hadoop. Hadoop is good for big data. For example, for 1 terabyte of news data that I have. So I started implementing with Hadoop. Hadoop was very good, but still I had a problem, because when you install Hadoop on one machine, you know better than me, right? It doesn't make sense that you install a Hadoop on one machine, even though it's parallelized the processing, still it's using only one machine. So I was lucky that time. I had many machines in the academia that I was working. So I installed Hadoop on many computers, many nodes. And because I was Windows user, it wasn't easy. That time wasn't many documents about the Hadoop. So I installed many virtual machines, installed Ubuntu on all of them, learning, configuration of them, and networking. And finally, I made Hadoop running, and I implemented again my project in Hadoop and run it. And what was the result? Failed again. Still, my accuracy wasn't that good. Still, my accuracy was low. The speed was good, but the accuracy wasn't that good. So I went back to my project, and I looked at my project again. I found that there are 2 problems here. The first problem is that when an event happens, for example, when demonstration happens, or war happens, or I don't know, there is an election in USA or something, usually the duration of that news or the time that affects on the market are not fixed slice windows, right? Sometimes it takes 2 hours, sometimes it takes 3 days. So I couldn't use exactly fixed chunks of the data for prediction. It should be somehow dynamic based on the event that is happening. So I should do the event detection based on the news. And for event detection, I should use clustering algorithm, right? Which is somehow unsupervised approach to find the best and similar news to each other. Another problem was that when news released, it takes, let's say, 30 minutes to affect the market. So always there is a gap, or there is a, what they call it, a span between the releasing of the news and affecting on the market. But I didn't know what's the best time for that one. I should run it many times to find the best or optimized value for that one. So what I did, I used the clustering algorithm, changing my problem, and to find the best approach. But you cannot run clustering on Hadoop, right? Why? You have an idea? Clustering algorithm is an iterative approach, and Hadoop is not working well with iterative approach like clustering. So I had to install Mammut on top of Hadoop, and I used Mammut to run the k-means. Also, there was a problem. K-means code was embedded in Mammut, and I couldn't easily change the code. So anyway, I ran this algorithm using Mammut, using k-means, and I succeeded in my project. Right? But the project took me around 5 or 6 months instead of 3 or 4 weeks. And it wasn't good. So I was very happy because I learned a lot in this project. And one day and actually casual lunch with some of my friends and colleagues, I was telling the story about how I started the project, how I installed the Hadoop and so on. And one of my colleagues told me, why you haven't used, for example, Spark. Spark is very cool, it's very fast and something. But the problem was I was really frustrated. I couldn't change my technology again. I had created my environment, all of my virtual machines, right? So for 2 or 3 years, every company that I went, I took all of this virtual machine and a hard disk, and I installed all of this virtual machine, and I ran my processing and data science things that I had, right? Because it was very hard for me that just jump to another thing, learn new things. So one day I was thinking about this project. I thought that I know about the machine learning algorithms. I know how the problem is going to be solved, and my approach was almost correct, right? And it only took me 20% of my energy, and 80% of my energy went just to install configuration, learning new things, re-implementation with Python, with Java, just configuration, installing all of this package, and so on. So I thought that I'm not really a data scientist, no offense, or I'm a data engineer, right? Because data scientist is supposed just to apply his knowledge, the algorithm that he knows on real world problem. It's not supposed to do configuration, integration of data, extracting data, and so on. So it's actually one of the differences between data engineering and data scientists, right? Data engineers are usually like plumbers. Just bring some data and clean it and integrate the data for us and make this ready for us, and we just run our algorithm to just take something sidetracked. So usually in this area we have data analysts, which are very close to BL, and somehow they are junior data scientists. We have, okay, some I see told me that we can tell about the salary. Their salary is usually in US around 65,000, 70,000. We have data engineers that usually do some kind of plumbing. Their salary is between 65, 70 to 100. Okay, they know good things about the Hadoop. They can easily handle different data sets, databases, big data. And we have data scientists, senior data scientists, that their salary start from 110 up to 130, 40. So my salary is not that much, but it's the difference between these three. And if you want to be in data science, or you are interested in this field, just be careful, don't fall in trap of data engineers, right? Because data engineers usually are doing manipulating data and so on. So anyway, I was one day in downtown Toronto, and I went to a meetup. I saw a guy brought up a website. Okay, he started writing Python code inside that website, and then runs a classification to classify something. After that, he sent that code for running on Spark, and then he closed it and told everyone that you can go and continue it at home. And I thought that is wonderful. You don't have to install anything on your computer. You open a browser, you have a place that you can start writing your code, and it's all on the cloud. And you have also a Spark, and it's really good. And that time I wasn't in IBM yet, okay? But later I found that it's Data Scientist Workbench. It's actually a website on the cloud. It's open source, it's fully free, and it will be free forever. It has a Spark and many open source tools. So what it has my data that you can put all of your data set there. It has 100 gigabyte data for free. So you have a space of 100 gigabyte. It has OpenRefine. Are you familiar with OpenRefine? Raise your hand. Yeah, OpenRefine is an open source project by Google. It was open source project by Google. You can use it for cleaning data, for reprocessing data, and especially it's very good for textual data. We have IPython notebook, Jupyter notebooks. How many of you are familiar with Jupyter notebooks? Okay, many of you. So it has Jupyter notebook and IPython notebook that you can run Scala, R, and Python code, and already it has connected to a Spark machine. It has RStudio. Okay, you don't have to install RStudio on your machine. It has RStudio on the cloud, so you can use RStudio to run R, and it's connected to a Spark. It has Zeppelin. Zeppelin is a new project of the Apache. It's still in incubation. It's very cool because you can run SQL on top of data frames in a Spark, whether than me, and you can use Zeppelin as well in Data Scientist Workbench. So, can we have a break for a few minutes? Yeah. So we can go for break, then we come back, I will show you some demos on Data Scientist Workbench and the work that I've done with Data Scientist Workbench. Okay, in this part, I will shortly just show you some demos on Data Scientist Workbench and show you how you can use Data Scientist Workbench to run your code. Just a question that some of your friends have asked. So, one of your friends asked me that Data Scientist Workbench is a bunch of open source applications like RStudio, like Jupyter Notebook, like Zeppelin, and we are using CPU, right? We are provisioning some CPU and also the space, 100 gigabyte space. Is it that part also free? Yes, that part also is free. So you can upload your data up to 100 gigabyte, and you can use the CPU. I don't know how many cores each one has, but I think it's powerful as a good laptop. Sometimes I run something on my laptop and it's not good enough, so I run on Data Scientist Workbench. And it has, I think, 8 gigabyte RAM as well. So it's like a good laptop that you have to run such a program. The Spark that already installed in Data Scientist Workbench is a local Spark with which is using, I don't know, 4 cores or 8 cores. So it's exactly the same as what you have on your laptop or computer. The good thing is, as soon as a new version of Spark comes, we upgrade the Spark, we upgrade R, Python, all of the packages that exist and usually people are using, right? So if there is a specific package that you want to use and doesn't exist in Data Scientist Workbench, you can install it. Pip install, blah, 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 right? Some packages need some kind of privilege you cannot install, but there is a place, user voice, you can send your request and in one day we will install for you. Actually, when we install for you, we install for everyone. And yeah, all of the packages that exist in R and Python will be upgraded. For example, if you are using scikit-learn, as soon as new version of scikit-learn comes, we test it. If it's good, we will upgrade it for you. Okay? How many of you have registered? I know that Power has sent a message yesterday that register for Data Scientist Workbench. Have you registered for that? Yeah, a few of you. Just a hint. The first time that you register for Data Scientist Workbench takes up to 30 minutes to provision this workbench for you, right? Because it's a system on the cloud and it should come out. So, but after the first time, it will be very fast and you can easily use it. But there is one point. If you don't use Data Scientist Workbench for, I don't know, 2 or 3 weeks, you don't log in at all, we will hibernate it because it's expensive for us, right? It's not that you lose your data, it's not that you lose your account, we just hibernated them. And next time that you open it, you should wake it up, right? And again, it takes around 10 or 20 minutes to wake it up. So if you use every day or wake camera, it wouldn't we go to the hibernate mode, otherwise it will happen. So before I explain about Data Scientist Workbench, I just wanted to go to Big Data University, just show you how it works. So the address is bigdatauniversity.com, and you can easily log in. So here you can see the list of courses and list of learning paths. For example, I can go to learning paths. And here are the list of learning paths. For example, click on Scholar. You can see that there are now 3 courses finishing. Scholar, Introduction to Scholar, Spark Overview for Scholar Analysis, and Scholar for Data Science. You can easily click on that and take the course. It's very simple, and you can take each of these courses, and at the end you get some kind of I don't know, certificate or badge. There are many courses. I'm not going to explain about the learning paths. I think it's very easy to understand the whole idea. Okay, let's go to Data Scientist Workbench. The address is datascientistworkbench.com. So if it's your first time, you have to register here. If you have already registered, you can easily log in. So it's an environment of Data Scientist Workbench. As you can see here, we have My Data, OpenRefine, Jupyter Notebook, Zeppelin Notebook, and RStudio. Okay, I will start with Jupyter Notebook because most of you already have worked with Jupyter Notebooks. So as soon as you open Jupyter Notebooks, you can see a list of my notebooks. Most probably when you open Jupyter Notebook, you don't see anything, just you see, for example, a recent notebook and recent data. Right? So if you want to create a notebook, you come here. You have option of Python 2, Scala 2, and Python 3. So let me open a Python 2. So you can start writing your code here easily, right? A equals 2 plus 2. You can click here and run it. And A, you can see your result. You can write all of your code here, and as soon as you finish, you can stop it and close the notebook. So I have prepared an intro to Spark for you, but most of you are already a Spark developer. You are familiar with this. I'm not going through the codes. I just want to show you that how it works. So let me see this one. So as you can see, you can add some photos, some markdowns to your Jupyter notebooks, right? I've added codes, markdowns, and explanation about Spark. Already, Spark context is provided as soon as you open notebooks. Spark context will be instantiated for you. So just if you write SC and you run it, you can see the result. So I just clean all of my output. So I just start running it. SC, it shows the context of SC. The version of my SC is the newest version of 1.6. If I'm not mistaken, it's the newest. So here we have an array. We can parallelize our array and run each cell by Shift Enter, Control Enter, or just clicking on this run. Each cell has somehow a designation, so when it's running, it shows some kind of response. As soon as the run is finished, you can see the results, right? So let me open another workbench here, for example. Here I have K-means Spark weather. I've prepared these notebooks for weather hackathon in San Francisco. So I think that it will be interesting if you look at the code here. It's supposed to be very fast. Okay, here we are. So there was a list of actually stations in, if I'm not mistaken, in Canada, yes, in Western Canada. I've downloaded weather stations report from Weather API, and this data set has station names, latitude, longitude of some stations, and temperature, precipitation, and other data related to each station in Canada. So I had two approaches to upload the data into Data Scientist Workbench, right? For example, here is my data set. I can open it for you. It's a CSV file, right? The station names, latitude, longitude, and so on. So the way that I can upload my data set, my data into Data Scientist Workbench is simply just drag and drop it into Data Scientist Workbench. As soon as it's finished, you can see your data here under recent data. So you can simply just drag and drop your data into Data Scientist Workbench. The second way is just to write a line of code to wget your data into Data Scientist Workbench. So I can easily run this line of code. I've already put the data set somewhere like Box, Inbox, Google Drive. I just download it into Data Scientist Workbench. And as soon as I download it, I load this data. You can see the file goes under resource folder. So the next step is cleaning my data. I clean my data. For example, I remove the header of CSV file here. I just find the first header and I remove from the whole file. The second part is preparing the feature sets. I just want to use three columns: latitude, longitude, and also temperature. I want to do the clustering based on only three features. So essentially, I want to find all of the stations which are close to each other and also have the same temperature, right? For example, if two stations are close to each other and have the same temperature, they should be clustered together. So here is my set of my feature set. Also, I wanted to just filter based on the station that exists only in the center of the Canada. So I define the maximum and minimum of latitude and longitude to filter my data. And then I use the PySpark machine learning library and call a standard scaler because I have to standardize my data because the temperature range is different from latitude and longitude, right? I have to normalize them between 0 and 1. So I did some kind of pre-processing here just to create some dense vector to convert the data in the normalized way. Next, I build my model. I've chosen 7 clusters to build my model. Cluster number is 7. And simply I use k-mean.train to train my model. At the end, you can see all of the centroids, right? The centers of each cluster after I run the clustering. So the first one is actually temperature, latitude, and longitude. So I can use this model now to predict my temperature. So for example, if I have latitude and longitude of the place, I can use this model to predict that whether it goes to under cluster 1, 2, or 3, or whatever. So for example, here I had one station, it's giving me temperature 48 something, its latitude is minus 123, its longitude is minus 40, and I use this data to predict the cluster of my station, and it shows me that the cluster is 2, right? So I can test it for more than one case, for example, 5 cases, and finally I can evaluate my clustering, what is my square error, sum of square error. Actually, sum of square error is the sum of the distances between the centroids and all of the members of the each cluster. So I can save the model easily, I can load it and use it in other notebooks. Also, I can visualize it, right? For example, I can use the matplotlib base map to visualize all of my stations. So I run, for example, here the piece of code that I use base map. Base map is a very popular package for visualizing the maps and this kind of thing. So it's running. I wait until it gets done. So here you can see it's all of the stations, right? So I have 7 clusters here. Each point is one station, and each number goes to the centroid of that station, right? So, for example, this station is usually very hot. If we come back to the centroid of each cluster, for example, cluster 6, I go up again, cluster 6. Here, I think this one is cluster 6. For example, you can see that the temperature of cluster 6 is very different from other clusters, right? And cluster 0, 1, 2, 3, 1 and 3 are very low, it should be very cold. See, 0 is the actually north part of the Canada, which is very cold. So it's the way that you can read the data, you use the machine learning library and do the cluster. So let me show you another example. I'm going to show you another work that I've done for Spark Summit in 2 months ago. This one is flight delay. Actually, I had a data set of all of the flights in the US between all of the airports. It's like Iris data set for machine learning community, right? Always, when you want to test something, you use Iris data set. For Spark community and big data community, always data scientists use flight delay. And this flight delay is record of all of the flights between the airports in the USA. The site, I just took the 2007, year 2007, and it's still 7 million flights, right? So it's not that big, but still the data set is big. So I just want to show you that how I use this notebook to analyze this data, importing all of the packages. I could actually drag and drop, but because the database was 600 megabytes, I prefer to just download it. I'm not going to run this part because downloading may take time. I've already downloaded, just I read that data set, and I start cleaning my data set. The cleaning is very simple, just separating each, splitting each column by comma because it's a CSV file. I create an RDD and a data frame. So let me clean all of my outputs. So let's run it from here. Okay, good. I clean my data set, I parse my data set, okay, and create an schema for my data set. One point, if you have used the Python to read a CSV file, right? I don't know if you have experienced this or not. If you read the CSV file using Python, usually the schema of the CSV file is not discovered by a Spark, right? It just gives you a list of columns, and you don't know which one is integer, which one is, I don't know, float, which one is a string, and so on. And you have to do it manually, right? Databricks has released something, a library for that one, but it only works using the Databricks, as I know. But in Data Scientist Workbench, we have a new library that helps data scientists to recognize the schema of data. So, for example, you have a CSV file, even it doesn't have any headers. You read using that library, and it tells you that it has 5 columns. The first column is integer, and most probably is currency. The second column is a string, and it can be, for example, name of persons, name of companies, drug name. So it has somehow it's very smart and can semantically tell you the data type of the column. So it's very good for cleaning your data, right? You have a big data set. For example, let's say you have 100 CSV files, and they don't have any header. So just put all of them into folder, and use the sparkling. It will read all of these files, it merge all of them, and semantically tell you that what's the data type. Not only what is, for example, integer, a string, or whatever, it also tells you that, for example, it's company name, its country name, its address, and so on. So it's a very cool tools that I usually use. So feel free to go and use it. There is a tutorial for that one in Data Scientist Workbench.
So I know that it's always a SaaS product. Is it in pipeline to make it available as a host your own version?
For now, it's not open source. It only has been installed in Data Scientist Workbench. But I know that in future it will be open source. We're creating a GitHub page for it, and we plan to just put there. Everyone can download it and use it for themselves. Yeah. Because it's just developed, actually, not more than 2 months ago. And it's because always our data scientists want something like this. We have developed, now still is testing. I can show you that how it works. Anyway, but this one we are not using as sparkling, it's pure Python code. So you can easily run it on your computer. So it's a sample of data frame that you can create for flights. It has arrival time, I don't know, CR arrival time, I don't know what's that, day of week, day of month, departure delay, departure day, destination, distance, month, and year, and many other fields. So what I'm going to do here is I'm going to use the logistic regression to predict the flight, right? So I want to create a model, and after creating the model, I use that model to predict, to see whether a flight is going to have any delay or not, right? So I add a new field here, and I set its value true if its flight is more than 50 minutes. I put it false if the delay for that flight is less than 50 minutes. So somehow I'm labeling my data set based on the delay that I have in my data set. So you can see now we have a new column here, departure delay. It's false, for example, for these two first records. So I also add hour. I take up hour from my date time, and I use it as a new column because I believe hour is one significant field and can have effect on my classification. So I also create hour fields for my data set. Then I start exploration. As you can see, I'm also again following the whole methodology of data science, right? Loading the data and cleaning and starting exploration. The first exploration is to see which airports have the most delay. So I register my data set, my data frame as Uh, uh, Actually, I register my data frame, and later I use Spark SQL to just run some queries based on that data frame. I'm not going to explain about all of these technical things because I believe most of you have worked with Spark already. Apollo told me that already you have passed 5 or 6 meetups, so I asked you to know about data frame, about Spark SQL, about all of these concepts. So here I map each airport to correspond longitude and latitude. I didn't have latitude and longitude, so I had to download another data set to just merge these two data sets. I had the station, actually I had the airport names, but I didn't know what's the latitude and longitude of them. So I found another data set that has all of the airport names and the private locations. So I merged these two data sets. As you can see here, I just downloaded that data set. It's called airport.dat, and I merged these two data sets. So now I have a new data set here with the longitude and latitude. So I've used a signal function just for coloring some values because I wanted to see the range of delays. And I'm going to show the plot that shows me the delay for different airports. Okay, here we are. So here we have different airports. In America, the color shows the delay. The reddish one means that it has higher delay. For example, I see, I don't know really this abbreviation, but these are the abbreviation of different airports. So it sounds that on East Coast we have more delay comparison with the other ones. Yeah.
The red one is Philadelphia.
Maybe, yeah. Okay, let's look at another exploration. The second exploration, I wanted to check that which roads usually have delay, not airports, right? So I started selecting the data based on the roads from one origin to destination, and based on the count of the flights and average distance, I wanted to calculate the roads that mostly has chance mostly to be has delayed that flight. So I again ran a SQL command to read all of the roads from my data. Just notice that for most of this visualization, I had to convert my Spark data frame to Pandas data frame and again go back, right? Because you cannot easily use visualization with Spark data frames. So I converted it to the Panda data frame. It's a bit takes time because converting actually Spark data frame to Pandas is a bit data to set up Pandas. It takes time. Anyway, it's done. Again, I used base map to this time. I just generate all of the roads between all of the airports and show whether it has a delay or not. So as it is running, you just map the roads because there are many roads. Yeah, here we go. So here are all of the roads between all of the airports to just see that which roads have most likely to be delayed. So these are all just exploration, right? Looking at your data and understand your data. I haven't started the modeling yet. So I'm going to focus on one of the airports, for example, JF Kennedy, and I took that one as my origin airport, and I want to look at what is the delay of this specific airport based on different months. Is there any month that it has higher delay or not? So focusing on JFK Kennedy, I again query my data. I create a data set here. I calculate total flights from this airport. Simply, it's just counting number of flights that its origin is from JFK. Okay, sounds that 122,000 flights only in 1 year, only in 2007. So I will put this data and I will look at this data based on different months. I want to calculate only average delay by months. So here's average delay by months for different actually carriers, right? I don't know what's A stand for, but they are American. Anyway, you can easily use some kind of plotting to explore the data. Still, I have another exploration. I try to jump this one. Actually, this one is to see. This one is interesting actually to just see whether the day of flight and hour of flight has any effect on delay or not. Is there any correlation between the time of flight and the day of flight or not? So I use a heat map to visualize the data. All of the flights from JFK actually. And here is the result. As you can see, for example, it has started from Saturday. Here is day of week. Here is, for example, Saturday, Sunday, Monday. As you can see, mostly Mondays we have some kind of delays in JFK, mostly because it's the first day of week and there are many meetups and we have many flights, especially between 8 to 10 morning and afternoons between 5 to 9 because flights are piled up in that time and we have many flights. So just we can see that which hours and which days mostly we have delay in JFK airport. We could run this one based on all of the flights, but I wanted to just focus on one of the flights. So now I start doing the modeling. For the modeling, the first thing I supposed to do is just do the feature selection, right? I have many features and I wanted to do the feature selection. If you're familiar with logistic regression works only with continuous values, right? Actually, your target value should be a somehow label value, but independent values should be continuous values, and it cannot be categorical values. But I have some fields like destination, which was very important for me. For example, most of the flights from JFK to San Francisco had delay, right? Or from JFK to, I don't know, New York or somewhere else. So destination was very important for me. And somehow I should decode my destination, which was the categorical value, to continuous value. So I used the machine learning pipeline, Spark machine learning pipeline, to do feature selection, to convert my features from categorical to continuous values, and so on. And here we have errors. Okay, first I create a destination index. For each destination I create an index. I know that I have more than 70 destinations, so I create a new column. We call it destination index, one index for each destination. Then I use destination index to create a destination vector. So I create a destination vector. You can see this one is actually destination index, 13, 14, 1, so on. And here are the dense vector that shows, for example, that it has 70 columns. This destination has 70 columns, and the column with index 37 is 1. So essentially, what we do in visualizing or binarizing the data to convert the categorical value to continuous, we create what they call dense vector, as far as dense vector, and we just put 1 for the value that it has 1 for that destination. So anyway, I create these values and I use assembler to just assemble all of the values, latitude, longitude, the destination values, hour, months, and all of these values that I want to participate in my logistic regression. After this feature selection, my data set is ready just to train my data. Here we can have a look on labeled data. Also, I have added labeled data, whether it has delay or not, true or false. I had to change true or false also to 1 or 0 because logistic regression only accepts 1 and 0. Finally, I run logistic regression to train my model. Before training, I had to split my data set in train and test set. So I use 70%, 30% to split my data set. And I use the train part to just do the modeling. Here I build my model. Wait until it goes long. You know that my data set is huge because it has more than 90 columns, right? For example, only for distillation, I have 70 columns because I binarize my data. Okay, my model has been run, built. So I want to test it. So I create a test asset. It doesn't show the coefficients, but I use true positive, true negative to just calculate the actually accuracy of my model. I could show the coefficients as well. Right? Just I calculated true positive, true negative to calculate the recall and precision. And based on the recall and precision, I will report the accuracy of my model. So for evaluation, again, I've used true positive, true negative to calculate the recall and precision, which is actually the common way to calculate the classifier's accuracy, right? So same as other classifier, I used the accuracy and I reached to 72% accuracy for my model. So the model is ready. Now I want to use that model to predict something, right? So I've used this model to create a widget, and using this widget, I can predict new flights, right? Notebooks has a very nice widget that you can select your data, and now it will be very fast because already I've made my model based on my trained data. Now I can just use this widget to select a specific flight, and it gives me the what's the cost of that flight, whether you have delay or not. For example, I select my destination. Let's say my destination is CLE, and I want to know that whether I have delay or not. For example, if months is 6, it sounds that I don't have any delay, but if I go to months 9, still I don't have. Day of weeks, for example, the first days are usually supposed to have a delay, so I put 3. And for example, 7 o'clock or 8 o'clock, it's supposed to change. Oh, let me check. I had one example. It's month 2, day 3, February, which is very cold. So I put 1, 2. That still doesn't apply. Day 3, because the flights that has delay in comparison with the flights that don't have delay are not that much. So CLE, month 2, day 3, 80. Sorry? I see. I tested slowly and it has. Let me just refresh this one. It's very hard to find a flight that has delay because it's very rare. And now it is still working. So it's why I put a sample case that it has delay. And it makes sense because 6 hours is peak hour for the flights for the airport. Third day is actually Monday, that some of the flights have delayed, and the month is 2.
This is delay because of the takeoff in JFK, or it could also be at the destination?
From JFK, it can be because of the destination, right? If you know any other, the boundary is still running. Yeah. Let me try one more time. So I put CLE, and for months I put 2, and for day of week also I put, for example, 3, and change hour to 80 or something. Okay, I don't know, for any reason, doesn't work now. So it's the way that actually you can play with the widget, and sometimes I've seen that it says that, okay, your flight has delay. So it's a demo using a 600 megabyte data, right, only for 7 million. What about if we have a very, very big data? For example, I don't know, we have 50 million data sets, right? So I have exactly another notebook is doing the same thing, but my data set is very big. It's for many years of the flights, from I think 1998 until 2016. So it's big data. I put this data set somewhere on the cloud on, if I'm not mistaken, it's on HDFS system. I want to load this one and run it. If I want to run same as this way, using notebook, it takes forever, right? So we have another option in Data Scientist Workbench. This one is a notebook with big data actually. Right, let's stop these things. This is the same data set with all of the codes, but instead of running one by one, each cell by each cell, I just go here and click on this arrow key, and I select submit to Spark cluster. If you come here to the size of data set, see it's on HDFS, and the data set is from 2001 to 2008, right? And the data set is very big. It's around 5 gigabytes. So what I do, I just click on this one and submit to Spark cluster. What's happening here? Data Scientist Workbench take all of the Python codes, they put all together, it creates a Python file and sends to the cluster. It's not local cluster anymore, it's on the cloud and it's a big cluster, and run that one for you. So I click on submit to Spark cluster. It creates a new notebook for me. Actually, it's generating the Python code. And it asks me that I put the address of the notebook that I want here, right? And will submit my notebook to this cluster. So I easily goes and put the address of my notebooks here. I can put insert L like this, and I run this specific cell. So see, it's coming to the Spark and submit the job to the Spark cluster. And it's stop running my cluster. So you have two options. First, use a notebook, local Spark is free, or you can use the submit to cluster. If your data set is huge, you can send for a cluster and it can be run. So, as while it's running, I want to show you something else. As I told you, there is RStudio also is Data Scientist Workbench. I am going to open RStudio here to just show you how RStudio is working. See, it's exactly same as RStudio that you install on your laptops. So you can start writing your code here. For example, A equals 2. And you can see the result, the variables. You can load your files, R projects, and so on. And you can easily use RStudio. Are you familiar with RShiny? Have you worked with RShiny? Yeah. Sometimes you create an R project, right? And you have a data set, you do some analysis. You want to publish it. right? You create a chart and you want to publish it. You want to show your manager or your friends. You want to share it. And you don't want to share your data set. You don't want to share your code. So you want to create an application, right? So you can use the Shiny R. And this, I don't know, it's R Shiny or Shiny R? R Shiny. This R Shiny is already installed for you. You can run this one and you can create an app and share with others. I don't know, we have time to demo it or not. Okay, it's like, I just ran it. If it's because it takes time to run application, I just run it. If it comes up, I will show you. Yeah, it's running. See, there's a part of code that I've written in R. It's a very simple R code. It has two parts, server and UI. UI is the part that you can show everyone. And here you have the application, right? And you don't have any code. So you can easily publish this application on web or show your manager or everyone. It's not like notebook that there are many codes there. So for example, here is one area of Canada and we have some stations there. Here we are showing the temperature of this station, salinity of temperature. It's actually related to a station in the ocean. So you can see many information about them. You can filter your data. You can select, for example, instead of this year, I want to have data of, for example, 1939 until some other dates. You can easily handle your data. For example, I want to have many data points, more than 41 data points, and you can interactively work with your application. Let's go back to the previous submit to the Spark. I hope that is finished. Yes, it has finished. And it's your result. If you look at the accuracy, 79%, right? If I use a small data set for 2007, my accuracy was only 72%. But here I've used a big data set and my accuracy is 79%. Last point is that you can easily share notebooks with others. So here you have an option that you can share a notebook with others. You can share a notebook on Facebook, on Twitter, on Gist, or you can create a link, and I can share this link with you. And as soon as I share with you, you can open it in Data Scientist Workbench. So for example, I can copy these links, go to Meetup page, and for example, I put it here.
Does it require that the other user also?
Yes. If you have registered for Data Scientist Workbench, as soon as you click on this link, it will be open in your Data Scientist Workbench, and you can run it. It's a very cool thing, right? You can easily pass all of the notebooks to everyone. So that's it. If you have questions, I'm here to answer all your questions.